Okay, in the last class we have discussed about the what is parallel computing. Okay, in the first hour we have discussed about the what is parallel computing, classification of parallel computing based on the Flens taxonomy. Okay, andre this is based on what here the number of instruction stream and also data stream okay. Based on this instruction stream and data stream, we have seen the SI, SD means single instruction, single data. Okay, SI, MD means here the single instruction, multiple data, and also multiple instruction, multiple data, and also multiple. Sorry, uh, yes, multiple instruction, single data stream, and multiple instruction, multiple data. Among these, we have the forward syllabus, SIMD and MEMD only. Okay. Already we have seen the SIMD means what? Single instruction, multiple data. We have seen the, we studied the vector processor. Okay. Vector processor and also characteristic of vector processors. And also we have seen the third one is what? Memory. And also we have seen the SIMD. Third one is SIMD. Okay, in that we have seen the taxonomy, vector processor, characteristic of vector processors, and also MEMD. MEM means what? Here the multiple instruction, multiple data stream. Okay, there are two types of here shared memory systems and also distributed memory access. Okay, distributed memory systems. Okay, and for the single core. Today we'll see the same with the MEMD only with the multiple core. Okay, in the chip. Okay, we visually have the single processor we are using there. Okay, now today we'll see the MEMD with the multiple processors. Okay, how the multiple processors are together taken into the one single chip. Single chip ಅಲ್ಲಿ ನಾವು ಮಲ್ಟಿಪಲ್ ಕೋರ್ಸ್ ತೋತೀವಿ. ಮೊದಲು ಏನು ಮಾಡ್ತಿದ್ವಿ, ಸಿಂಗಲ್ ಕೋರ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ. ಬಟ್ ಹಿಯರ್ ದ ವಿಲ್ ಬಿ ಕನ್ಸಿಡರಿಂಗ್ ದ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಮೆಮೊರಿ ಸಿಸ್ಟಮ್ ವಿತ್ ದ ಮಲ್ಟಿಪಲ್ ಕೋರ್ಸ್. Distributed memory systems using the multiple cores. Okay, using the multiple cores. Okay, in the distributed memory system we have the widely available distributed memories are called as the cluster. Okay, this kind of distributed memory is called as the cluster. Okay, cluster type. And also we have the here the usually we will be connecting each and every processors. Okay, chip one agade idu shared memory system agidena. In single chip you have the core 1 core 2 agidena idu illala agillala. Okay, okay. Shared memory system with the multi-core and also okay. Now we'll consider the shared memory. First one we'll consider the shared memory. Agadre but with multi-core agada illa agilla. Okay, shared memory system with the multi-cores. Okay, usually the multi-core, the most widely available shared memory systems are use the more than one core in a single chip. Earlier we are using the single separate CPUs for the connection for accessing the different types of for you will be using the different cores, one or different cores on a separately to access the memory. But here the will be taking the multi-cores on a single chip. Okay, here means what? Here the two cores on a single chip. Okay, typically we have the and also even we have the we'll see. Okay, shared memory system. core 1, core 2, and also core 1, core 2. Okay, this is the chip 1, this is the chip 2. Okay, okay, shared memory system will be sharing the is to be able to access the memory through what here the interconnect interconnect through the to the memory, to the memory. Okay, the same I'll be using the same with the, this we calls the shared memory system using the multi cores. Okay, in a single chip we are using the two cores here. Each and every core will have the its own private level of cache. These caches cannot be shared to another core. Okay, usually the each and every core will have the of its own private level cache. These caches cannot be shared to the next core also, next processor also, to the another processor also. But here the chip one, okay, in a single chip we will be having the multi cores, means more than one core will be built in a single chip. But here the this memory chip, okay, these cores has to be access to the memory through what here interconnect. Okay, usually these cores will have its own private level of cache. Okay, these cannot private, as the name suggests, itself suggests that these are the cores will have the private. Okay, these caches, okay, these cores have the cache. Okay, this cache cannot be shared to the another core. Okay, another core means what here the whatever the cores will be having the uh, okay, caches that cannot be shared to another cores of the any chip. This in this in here only it cannot share to another core also on a single chip. Even it cannot share to the another chip core also. But here if you want to access the memory, okay, shared memory, we can share the memory through what here the interconnect only, interconnect. Okay, okay, this one is called as the uniform uniform memory access, memory access memory access multi-core systems, multi-core multi-core systems. Okay, multi-core systems. Okay, as you already studying the, we are studying the multi-core system for the shared memory system. In the shared memory system we have the here the you are the we have the multiple number of cores. These multiple number of cores, more than one core is built it on the on a single chip. Okay, these cores will have the of its own private level of caches. These caches cannot be shared to another core. This is the main. Okay, even the chip one cores can share their memory, can get that can access the memory through what interconnect. Okay, usually the next chip also can be sharing. Okay, can access the memory, main memory. Okay, through what here the interconnect only. This one is called the shared memory. But here the what we are saying this, it's the uniform memory access. Here the uniform access, uniform memories. Why the uniform memory access means what here the it is having the, if so accessing the time interval is same here, we will not change the time. Okay, it will not be changing here. For the accessing of this memory chip will have the same time as the same as usual. But in the non-uniform, okay, same figure, but thing is that will be having the separate main memory. We are with the accessing the memory. Okay, shared, we are sharing the, we are getting the memory is accessing to the single memory. So the main memory is shared to the one chip to chip one chip two with the same. But here the non-uniform memory access system will have the same. Okay, as usual. But thing is that here the time for accessing the time will be different from one to another, one to another. Okay, interconnect is the separate interconnect will be using. a separate interconnect I am using here also, but the main memory for this one is the same. And also we'll have the, okay, this one is the two directional bidirectional, no, this we call as the what here, buses. Okay, this cannot be, this can be shared here. Okay, this one we call as the non-uniform non-uniform memory access multi-core multi-core systems. Okay, multi-core systems. Okay, just to copy these two figures, I'll be explaining this one with one more time. Just to copy that one. Just to copy the figure. Okay, most widely used, okay, nowadays most available widely available is the shared memory system. Use the one or more cores on a single chip. Okay, multi this multi-core process has its multiple number of CPUs on a single chip. Usually, the each and every CPU, okay, each and every core has its private level of caches. This cache cannot be shared to the another core. Okay, this is the private level cache. Okay, okay, even the cores, okay, even the cores of the chip can communicate. Okay, can access the memory locations through the interconnect. Okay, each and every time. Okay, this one we call as the uniform, okay, uniform memory access multi uh, multi-core systems. Okay, multi-cores, because we are using the more than one course on a single chip, because even we are communicating to even we can access the memory locations to the through the interconnect each and every single course, also even the single course. But here the course can have the its own cache. This cannot be shared to another course. Okay, okay, even uniform, why the name has uniform memory access means what here, the whatever the accessing the memory locations, each and every core will have the same time here. Okay, it will not have the one another different times here. If it's a core only accessing the memory locations through the interconnect, and even core to also have the same memory same time. That's what the uniform memory access multi core system is the given name. Okay, main advantage of this one is the programmer can easily program with the help of fun. Even the programmer cannot wait for the accessing the memory of the memory locations of the memory locations. Okay, even because it's having the uniform time. Okay, if compared to this UMA memory multi-core systems, this one is what non-uniform memory access multi core system. Okay, this is here the main here the we will have the different types, and even these multi cores this can be interconnected to the buses. Okay, okay, and even the if you want to access the main memory to the cores will be having the quick access. Okay, because of the chip one. Okay, chip one can have the less time compared to the chip 2 processor. Okay, that's what the here the non-uniformity for accessing the memory location is the different times. Here the same time for accessing the memory location for the in the UMA means uniform memory access multiprocessor multi-core systems will have the same time, but here the accessing of the main memory locations to the core one of the chip one may be quickly be less time compared to the core one of the chip 2. That's what the here the name given as the non-uniform memory access multi core systems. Okay, multi-core system. Okay, main advantage of this NUMA is what here the we can solve the larger problems. Okay, we can solve the larger problems. Main advantage. Okay, this is the main advantage. This is the main advantage of this is the programmer programmer can easily access the memory locations, can easily access the memory location while programming. Okay, while programming. Okay, these are the two types of multi-core systems we are having here. Okay, sorry, shared memory system with the multi-core I'm having here. Okay, okay, take the some notes. Okay, multi-core processor has multi-core processor has multiple CPUs, or cores on a single chip. Multi-core multi-core processor has multiple CPUs, multiple CPUs, or cores on a single chip, or cores on a single chip. Okay, okay. Typically, typically cores have cores under CORE, core under processor. Okay, cores. Okay, usually typically the cores have private level of cache, private level one cache, private level cache one. Cores usually have the private private level one cache, private level one cache. Okay, private level one cache, while other caches may or may not be shared between the cores. Okay, each and every core has its own caches, but here the shared memory system have the cores usually have the separate cache also. That cache name is what here the private level one cache, private level one cache. Okay, other caches cannot be shared with the cores of the other systems also. Okay, may or may not be shared with between the cores, while other caches may or may not be shared between the cores, other cores. Okay, multiple multi-core processors in this multiple multi-core processors and the interconnect the interconnect can connect all the processors can connect all the processors directly to the main memory, to the main memory, to the main memory. Processor can access the next processor can access each other blocks of each other blocks of main memory main memory each other blocks of each other's blocks of main memory through special hardware through special hardware built into the built into the processor. Okay, in the shared memory, okay, I said, in the uniform memory system you will have the less time, you will have the same time to access the memory locations of the memory locations to the core here, same time. Okay, that's what we given the same time in the select now in uniform memory access multi core systems ಕರಿತಿದ್ದೀವಿ. But in the main advantage of this uniform memory system access multi-core system is what here the programmer can easily access the memory locations easily while programming. Okay, in the non-uniform, okay, in the non-uniform memory access multi core systems will have the different cores on the chips, but here the for accessing of the main memory we will be having the quick. Okay, chip on cores can have the less time compared to the chip to cores of this one. Okay, that's what the here the accessing time will be different here. That's what the name given you as the non-uniform memory accesses. Okay, take the in the first. Okay, I hope you will copy that one. You'll write off your own. No, ಬರ್ಕೋತೀರಾ ನಾನು ಹೇಳ್ಬೇಕಾ? Okay, in the first type in the first type system in the first type of a system, the time to access all the memory locations the time to access all the memory locations will be the will be the will be the time to access all the memory locations will be the same be the same for all the cores will be the same for all the cores, while in the second type of system means you have the non-uniform system. Okay, in the system the non-uniform systems non-uniform system, the memory locations to which the memory locations the memory locations to which a core is directly connected a core is directly connected can be accessed more quickly can be accessed more quickly than a than a than than a memory location that must be accessed through another chip. memory access Memory locations that must be accessed through another chip another chip another chip. First type is called as the UMA, means what? UMA multi-core systems. First, second one is called the non-uniform memory access multi-core systems. Because why we calling? Because of the we are using the same time to access. The second one is the will have the different times. That's what the name. Mean first type will have the what here the advantage here. Programmer can always easily access. Next point, advantages of UMA UMAR. Okay, UMA advantages of UMA is easier to program, easier to program, easier to program since easier to program, easier to program since programmer does not need to worry about the different access times, because since programmer does not need to worry about the different access times for the different memory locations memory locations. Okay, main advantage of the NUMA is that here the non-uniform memory access systems here having the okay potential to use what solve the larger amounts of memory than the UMA, and also even they can be used okay larger memory, and also when mainly larger memories will have the larger problems will have the this larger memory. This can be accessed. Okay, this larger memory can be accessed through the non-uniform memory access stream. Because okay, this is all about the shared memory with the multi-core systems. Okay, multi-core system. Now, multi-core system. Now we'll go through to the distributed memory system. Okay, distributed memory system using the multi-core system. Okay, these are the distributed memory system usually called as the cluster type. Cluster type. Okay, cluster type because of the they can available. Okay, the cluster type they are compared to the composed of the collection of commodity system. Okay, usually commodity andra commodity systems. Commodity ಅಂದ್ರೆ general useful things. Okay, the daily useful. Okay, even okay these can be if you have the more pieces. Okay, usually pieces are connected to the interconnection through the more pieces are connected one by another with the help of what ethernet. ಈಥರ್ನೆಟ್ ಅಂದ್ರೆ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ಅದು ಇಂಟರ್ನೆಟ್ ಸಲಗೆ ಹಚ್ತದ್ರ ಮುಂದಿಂದು ಪ್ಲಗ್ ಏನಿರ್ತಲ್ಲ ಅದಕ್ಕೆ ಇಂಟರ್ನೆಟ್ ವೈರ್ ಇರ್ತಾ ಅದ್ರ ಮುಂದ್ಗಡೆ ಒಂದು ಅದು ಇದಿರುತ್ತಲ್ಲ ಪ್ಲಗ್ ಅದಕ್ಕೇನಂತಾರ ಈಥರ್ನೆಟ್ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ವೈರ್ ನಾವು ಪಿ ಸಿಗೆ ಏನಾದ್ರು ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇಂಟರ್ನೆಟ್ ಕನೆಕ್ಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಮುಂದ್ಗಡೆ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಇರ್ತದಲ್ಲ ಚಿಪ್ ಥರ ಇರುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಈಥರ್ನೆಟ್ ಅಂತಾರೆ. ಓಕೆ okay, for example pcs are connected to the commonly through the help of what ethernet. Okay, ethernet. Okay, in fact these one by one systems usually connected to the through what here the networks. Okay, networks. Okay, these distributed memory systems usually connected to the one by one with the help of the networks. Okay, networks. Okay, and also even the will be having the if you are connected. Okay, usually distributed memory systems are called as the hybrid systems. Okay, hybrid system because of we are connecting the more than one multi-core systems here. Hybrid systems. Okay, and also nowadays we are using the everywhere in the multi-core distributed memory system with the multi-cores only. Usually okay, usually grid. Okay, the grid usually provides what here the infrastructure to develop the build the our yeah, multi-core systems. Okay, multi-core systems. Okay, even the mainly these using the grid. Okay, if you use the grid system, if you develop the distributed memory system using the multi-core, usually we call as the these systems are called as the what here the heterogeneous heterogeneous. Okay, heterogeneous. Okay, individual nodes. Okay, each and everywhere. Okay, got it. Okay, distributed memory systems are called as the cluster type. Okay, even the each and everywhere you are using the nowadays everywhere this can be used a commodity system because commodity system every time you are using the multi distributed memory systems use the multi-core only. Okay, usually the more than pieces. Okay, for example pieces one more than one pieces are connected to the another through the ethernet. Okay, with the help of ethernet. For example, if the one by one if you want to connect the one system to another system which will be which will be done with the through the networks. Okay, networks. Okay, usually the if you connect it to the memory distributed memory systems this multiple cores with the if you access this one if you, this we call types of parallel systems are called as the hybrid systems. Hybrid systems. If you want to develop this distributed memory system for using the multiple cores, this can be done achieved with the help of the grid system. Okay, grid system. This grid system is what here the somewhat it's a skeleton. Okay, for developing the multiple core systems. Okay, this type of if I develop the distributed memory system with the multi-core systems, these types of multi-core distributed memories are called as the heterogeneous. Okay, this is all about the distributed memory. Just to copy whatever I written on the board, just to copy that much only. Copied. Okay, next we'll consider the interconnection networks. Interconnection networks. Okay, okay, interconnect networks plays a main crucial role, okay, in the programmable for both the distributed and also shared memory systems. Okay, if you want to connect the systems which will be done with the interconnect. Okay, this we call as the interconnection networks. Okay, interconnection networks plays a main role. Okay, main role means what, in order to work with the for the shared memory system and also distributed memory system. Okay, it will be give the good performance. Okay, if you are studying the good performance here. Okay, okay, in this we have the shared memory networks, and also in this also we have the same type only, but here the every time we'll be using the shared memory networks, and also we have the distributed memory access. Okay, okay, in this also we have the two types only, the shared memory interconnects, and also we have the and also distributed memory interconnects. Okay, first one we'll consider the shared memory interconnects. As you know that each and every systems usually functional units are usually connected to through what here the buses. Okay, buses. Okay, these buses okay, these buses will be we have the parallel, okay, the parallel wires, the parallel number wires, okay, this can be communicated to the buses, can communicate it to the another system through the what here, the parallel communication of the wires, okay. At the end of the wire will have the some network, some devices, okay. This can be, this is called the bus, okay. This one called the buses. It means what here, the, as we already know that shared memory system uses the connect to processor to memory through what here, the buses, okay. You already know buses will be indicated with the bidirectional, okay. Bidirectional one. If I have the bidirectional means what here, the we are accessing the memory locations even data, but for the address of that particular memory location will be having only what here, the single direction. If it's a data, if it's a want to work with the address, we'll be having the only single direction. If you want to work with the memory locations, we'll be having the bidirectional buses, okay. Bidirectional buses usually have the parallel number of wires, parallel number of wires through which will be communicating to the another course throughout here the buses, so wires, okay. These wires at the end we have the connected to each other, okay. Usually the buses, whatever we are using buses, this will be low cost, low in cost, okay, low in cost, okay. Even the flexibility of the connecting to the shared memory systems through the another course usually more here, but if you want to communicate to the more than two cores, more than 10 to 20 cores, will be using the same bus every time. The flexibility will be less here, so that the ಈಗ ನಾವು ಒಂದೇ ಬಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಏನಾಗುತ್ತಾ, ಇಲ್ಲಿ ಬಸ್ಸಿಗೆ ಒಂದು 10 ಕೋರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ, 10 ಕೋರ್ಸು ಅದೇ ಸೇಮ್ ಬಸ್ಸಾಗಿ ಶೇರ್ಡ್ ಮೆಮೊರಿಗೆ ನಾವು ಲೊಕೇಟ್ ಮಾಡ್ತಿದ್ವಿ. ಈಗ ಇದು ಒಂದೇ ಆದ ಇಂಟರ್ ಕನೆಕ್ಷನ್ ಒಂದೇ ಆದ ಅಂತ ಇಟ್ಕೊಂಡು, okay. If you are using the same bus here, same bus here, same bus here, if you are using the same bus to the communicate to the next core, even next core also more than 10 to 20 cores, then the flexibility will less, okay. But where the cost and will be less, but cost would be less, but thing is that here the we are sharing the, we are using the same bus here, so we are using the same bus here. That's what the we'll be waiting for the accessing the memory locations of the memory. And even the ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಅಂದ್ರೆ ಸೇಮ್ ಬಸ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಫ್ಲೆಕ್ಸಿಬಿಲಿಟಿ ಲೆಸ್ ಆಗುತ್ತಾ, flexibility less agata, okay. But buses can be used to connect from one system to another system. Buses are called as the parallel wires, will be using for 10 to 20 wires for the with the parallel communication purpose buses, okay. These buses would be are the low in cost for, but if I use the same bus for the many course, that time the flexibility will less, okay. For the flexibility will be less, okay. The flexibility will be less, okay. In the since the course wires are used more devices connected to each other, okay. Then the flexibility is less means what here, the performance of the performance of the will be less, okay. Performance will get the less, okay. Similarly, in order to connect the large number of cores, in order to connect the large number of cores, now ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ವಿ, 2 to 4 ಅಷ್ಟೇ ಕೋರ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ, ಯು ಯೂಸ್ ದ buses. In order to communicate with the more than the 2 to 10 cores processors, will be using the switch connect networks, okay. Switching networks, okay. If I use the, okay, switching network, instead of using the buses, I'll be using the switches network, switched interconnects, switch interconnects, switch interconnects, okay. In order to get the larger number of, okay, larger number of cores, in order to communicate one another with the help of the buses, it's not possible, okay. We'll be having the less performance there, we'll be getting the less performance. In order to get the more performance, we'll be using the switch interconnects. ಏನಾಗುತ್ತೆ, we'll be using the here the only 2 to 4 cores, okay, with the help of the bus. And if you want to use the more than the 10 to 20 cores for with the help of the bus, it's impossible, okay. You can communicate, but here the thing is that the low in cost, main advantage is low cost, okay, but the flexibility will not have that, okay. Will not communicate. If you want to communicate to the 1 core to the 10 core, there will not get the in the bus. If I use the switch interconnects, switch interconnect ನಾನು ಏನಾದ್ರು ಈ ತರ switches use ಮಾಡಿದೆ instead of buses, if I use the switch interconnects, there I can communicate from the 1 to 10 with the small path. Okay, small path. Okay, we'll discuss that one with the figure only. We'll not understand now. Okay, as the name suggests. Okay, switch. Okay, switch usually calls the switches usually called as the crossbars. Okay, crossbars. Okay, crossbars can have the more than three or more than five faces also, but here the bus can have the only two face here. Okay, either of our side we can connect, we can communicate, but switch bar switches will have the same, sometimes called as the crossbars. Crossbars will have the more than five connections also, more than five connections, more than four connections usually we have the if one you can have the five connections also. By that we have the more flexibility here. There are the flexibility was less. Okay, because of the two phase buses we are using. But here the switch, okay, switches are nothing but the crossbars can have the more than four also, more than four also. That's what we have the flexibility. If you want to communicate from the core 1 to core 5, there in the buses it will take the more time. Okay, flexibility was not there. But in the, if I use the, instead of buses, if I use the switch interconnects, this is possible. Here the flexibility is more here. This switch is main example of this switch is here the crossbar. Okay, crossbar can have the more than four faces also. Okay, more than four faces also. Okay, for this one crossbar will be more powerful, and even the, in order to connect the one core to the another core, this is possible. Okay, it's possible with the crossbars. Okay, crossbars usually we have the figure like this. Okay, usually we are communicating to the memory locations. Yes, na, now we can communicate but the processor with the memory, with the pair of memory and processor we are communicating. Okay, really these are the crossbars. Okay, these are the crossbars. Okay, this is the P1, P2, P3, P4. Okay, P is nothing but the processor. Okay, here the M is nothing but the memory. M1, M2, M3, M4. Okay, M4. This would be connected to the one another with through the bus, through the bus, through the bus. Okay, just to connect to each other through the bus. Okay, sorry. Okay, even we have to connect with the this one also. Here it is very easy. Okay, the switch bar here, whatever you're using here, the cross bar here, the I can if you want to work with the multi processor P with the even the M3 also, memory location M3 also, it can communicate with the very less path, in the small path only, because it's a crossbar is helpful for us to get this one. Okay, crossbars can have the two forms here. Whatever I've written in the circle, that can have the two ways as the. Okay, just to copy these two figure, I will explain. Okay, this figure is what here, the crossbar. Okay, this is the crossbar figure. Okay, okay, usually the crossbar you can have the switching the from the four processor to the four memory locations with the help of what here, the switches. Okay, this one we call as the mesh type or crossbar. Okay, usually the this circle whatever I shown here, this one is the switcher, this is the open switch, this is the closed switch. Okay, usually these two types of configuration we can use the in the while explaining the switches here, mesh type of memory location access with the processors. Okay, just copy that figure. Okay, this is the memory one, two, three, four. This is the processor one, two, three, and four. Okay, just to copy it. I will explain it. Okay, in the figure one, okay, this is the crossbar switch. Okay, this one we use the four memory and the four processor. Okay, these four memory processors are be used for the crossbar switch connection purpose. Okay, if I take the particular circle here, this one can have the two types of configuration. This is one type, this one the second type. Okay, this is the configuration of the crossbar. Okay, this okay, we can have the two types of configuration of the crossbar. This is the first one, this is the second one. Okay, this one is some type, so looks like a open. Okay, it's not connecting anything here. Okay, is the some not, it's connecting to the processor to the memory, processor to the memory. Here it's a memory connecting only, it's not connected to any processor here, it's not connected to any processor here. Okay, okay, in the third figure. Okay, in the third figure we have the four memories and four processor here, four memories and four processor. If I use the, if I use the, if you want to access the particular p3 here, p3 means what, processor 3 here, processor 3 here. Let me complete this figure first. Okay. In this figure, we have the memory and the processor. Memory and processor can be accessed connected to each other with the help of the crossbar here. Crossbar. Here we get the confusion. Okay, memory and the memory how to be connected to each other. Okay, we get the confusion. Okay, usually the crossbar, whatever the shown here, the switch crossbar, we can have the two configuration. One is here, second one is here. Okay, if I use the if I want to access the communication between the memory locations to the processor, I can do it to the help of the simultaneous. Okay, if I access the P3 is accessing what here the first one is what here the P1. Okay, P1 is accessing here. P1 is accessing the M4. P1 is accessing M4, and also P2 is accessing what here the M2, M2, M4, M2. Okay, M ಇಲ್ಲದ M3. Okay, M3 and M4. Okay, M3 and M4 are be accessed by the P1 and P2. Here the first one is called as the for accessing the M4 we call as the write. Okay, right, and this one is called the read. This one is the read. P3 na P4 P3 read and write. Okay. Okay. Here we are accessing the with the help of the switches or crossbars. Here with the help of the switches crossbars for writing and read purpose. If you want to access the memory location P4, we can access through what is the processor with the help of write operations here. We are writing to the memory location, and also we are reading from the memory location M3 with the help of the processor P3 here. And also similarly simultaneously we are using the with the different types here the reading. Okay, read from the P3. Okay, from the memory location M1 we are reading to the processor P3. Okay, we can writing the processor some locations, some values, whatever we are getting the values that can be written on the what here the memory location M1 memory location M2 through the P4. Okay, here we are doing the simultaneous operations here. Okay, simultaneous operations. If you are writing the writing to the memory locations with the help of the processor P1, and also if you are read operations reading from the memory M3 to the processor with the help of the crossbar here, and also we are also simultaneously we are doing the same operations here also, write and read operations to the with the help of the to the P3 and processor P3 and P4 to the M2 and the M1 simultaneously. Okay, main advantage of the crossword switch is here the we can faster. Okay, we can do the operations. Okay, read and write operations faster manner, but in the help of in the buses. Okay, we will be using the for read write operations sir will take the more time, and also there were we are not getting the flexibility, but here we have the we can do the more than two operation, more than one operation, read write operation at a time with the help of with the different memory locations, and also processors. Okay, with the help of what here the switch cross switches. Okay, cross switches. Okay, I hope you all copied this one. Okay, write it. Crossbar is a simple and powerful. Crossbar is a simple and powerful example of the switched interconnect. Switched interconnect. Crossbar is a simple and powerful example of the switched interconnect. Okay. In the figure one, in the figure one, in the figure one shows the crossbar, crossbar. In that figure, lines are bidirectional communication. Lines are lines are lines are figure one. Okay, lines are bidirectional. Okay, squares will have the squares will have the square will have the memory and the processors. Lines are bidirectional communication links. Bidirectional communication links. Squares are the squares are the cores and memory models. Cores and the memory models. Circles and circles and switches and also circles are the switches. Okay, just to write it as the squares and are the squares are have the memory and the cores processors, and the lines are the bidirectional, and circles are the what is the switches. Circles are the switches here. Individual switches can have the two forms configuration. Okay, these are the switches here. These are the switches. These are the switches. Okay, these switches can have the two forms. Okay, individual. Okay, this is one form. This is the another form. If you want to, this is the what here. The if you are not using the crossbar here, switches, it's the ideal one. This if I use the if I want to communication between the memory and the processor, then I'll use the this kind of configuration switch. Okay, this one is the, for example, if you consider the, in order to access the read write operation between the processor and memory, we can do the processor M1, processor P1, we can write to the memory location M4. Okay, if you want to read operations to the memory operations memory location M3 with the help of P2, and also simultaneously we'll be using the in the opposite manner read write operations right to the memory location we can done with the help of the processor P1 P4, and so read from the memory location we can do done with the P3 processor. Okay, we are using the simultaneously. If you want to communication between the any memory location to the any processor, we can done with the help of the switches here. It's compared to the processor buses, it's very easy to compare to that one. Okay, main advantage of this switches is the cross bus we cannot wait for the any much faster. Okay, we cannot wait for the do the operations of the first one second one. It's compared to the, if you want to communicate between the processor P4 to the M2 also, we can easily communicate. We cannot wait for the time also, it will not consume time. And also cost compared to the cost to the compared to the buses, the switches and the switches will have the less cost compared to the buses. Okay, we have the bulk will be producing, and also we have the small in size, and also we can easily communicate. Flexibility is more, and also cost compared to the buses, the switches can have the less cost also. Okay, next one is consider the distributed memory interconnects. Still, till now we have seen the shared memory interconnects. Now we'll see the distributed memory interconnects.